I'm gonna go with, I don't know, Lauren?
But you didn't do same line.
Oh, my.
Really?
Okay.
All right, awesome.
This is like the line that makes sense.
That's how I felt about the circles.
All right. All right, so there is a connection, but we're gonna like. You'll see it at the end of next hour, there's a connection between circles in here. Yeah, we're doing 13.1, which is on solving two equations. And then 13.2 is solving three or more equations. And when I mean solving them, I mean like simultaneously. So 13.1, they're called systems of equations. In 13.1, they call it the 2x2 system because there are two variables and two equations. There are two methods. Substitution method, which I will do last, which is the least effective. It's the biggest pain in the ass. Like my class. Right? Well, so we'll do that last. The other one is called the elimination method, and this works for everything really well, and it's not really complicated. It's also called the addition method. So let's focus on that. We're gonna go with as simple as fucking possible. Give me a number, Lauren. Give me a number, Megan.
8.
You guys made this equation. These equations. So we got two equations and two variables in each one, right? They tend to say two equations, two unknowns is the other way of describing two variables. So you'll hear two equations, two unknowns. The idea is goal for the elimination method. Equal, but opposite coefficients. Like +7 and -7. Those are the same in value, but equal signs. I'm going to abbreviate EBO from now, equal but opposite. When I'm writing it from now on, I'm going to call this EBO because it gets be a pain in the ass to write it just for lecture purposes. Do I have that right now?
No.
Yes.
Yes.
Why do you think no, Jackie?
I don't know.
You're just guessing. It's good. You got a 50-50 shot. It's worth a try.
Right?
If I do, which one? Why? Why here? It doesn't have a coefficient, so let's just put them in. So this one is +1y, and this is -1y. +1 and -1 are equal but opposite. So I'm gonna go back down here because that fucking one is bothering me. So I'm rewriting it without the ones there. So when you have them, the other reason it's called the addition method is that's what you do. Add to eliminate the EBO variable. So if I add x plus x, I get 2x. Y and -y is 0y. And 2 + 8 is 10. So we get 2x = 10. We divide by 2 and we get x equals 5. And then we need to find y, plug it into one of the original equations. Plug into an original equation to get y. So if I put it in the top one, 5 plus y equals 2. So I get y equals -3. I'm just gonna do the other one and show what happens if you plug it in there. Negative y equals +3, so y equals -3. The solution is an ordered pair, is a point, it's a point. It's both the 5 and the -3. Yeah,
In this instance, would that be like a vertex?
I'm gonna show you. Just waiting for everybody to look like they're done writing. Anyone need this longer? Okay, I'm gonna bring the next page forward. Let's sketch x plus y equals 2. And x minus y equals 8. This turns into y equals x minus 8. And this turns into y equals -x plus 2. So y equals -x plus 2 goes like this. Which is my x plus y equals 2 line. Y equals x minus 8. Connects those dots. Or x minus y equals 8. This point right here is 5, -3. Coincidence that the solution to our system of equations is 5, -3, and where these two lines cross is 5, -3? No. Values that solve both equations have to appear on both lines. Does that make sense? It's gotta solve, if it's solves an equation, it means it's on the line. And so for it to solve both equations, it has to be on both lines. Which in this case means intersection. There are 3 ways this happens, three outcomes going on here. Outcome 1, intersection, just like we saw. A single point. Boom. So this is where M1 does not equal M2. If you were to look at it in that form. Option B and C actually both have M1 equals M2. Parallel lines. I can have two lines that are in parallel. They're gonna have different y-intercepts. These don't cross. There is no point on one line that solves the other line, that works on the other line. So here, there's no solution. And C, it seems kind of lame, but it does happen on occasion. Overlapping lines. And the lines are like right on top of each other one. In fact, if you simplified the equations, they would look, you could get them to look the same. You would end up with y equals mx plus b is the same for both lines. So any point on one line, any point, no matter where you're at on the line, works on the other line because it's the same line. This has infinite solutions along the line. Giggle for me, Keith. You're not giggling. Feel like you don't care about me anymore.
That one got kind of wet.
Yeah, it is juicy.
No, but it is eggy. I haven't got a whiff of it yet, but the last two or three have been eggy. I'm just gonna assume. So don't come up here. It's for a while.
How many eggs did you eat?
I had 2 boiled eggs with breakfast. Slice them, put them on a bagel with cream cheese and some green onion. It's fucking delicious.
I ate 5 raw eggs this morning.
But that's a lot of eggs. Raw?
Yeah.
The fuck is wrong with you?
I did get on.
That's some psychopath shit right there. All right, let's do another one. All right, so now we have a little bit of dilemma, right? They're not equal but opposite already. So let's force it through multiplication. I'm gonna do it both ways. I'll do X's first and then I'll come back and do Y's. So like pick a variable to work on. Let's work with X's. So what you kind of want to do, no matter what the variable is look at the coefficient for the other equation. And multiply by it. And then B, if they're not opposite in sign, change one of the signs. Alright, so. You get a second to finish writing that instruction set down, but then we'll. Do it, I'm gonna kind of like do it visually. We're gonna take this 2, we're gonna multiply this equation by it. We're gonna take this 3. And multiply this equation by it. I think you can see in both circumstances, I'm going to end up with a 6x for the first thing. We want to make them positive 6 and negative 6. So this is where part B kicks in. Make one of them opposite. I'm going to turn this 2 into a negative 2. I can choose which one I wanted to do. I chose the 2 because it's a smaller number. But it's your choice. Dealer's choice. So that'll make this a negative 6x. We go through and we finish distributing that 3 to all of them. So 6x plus 9y equals 6. And now I'll do the same thing here with the negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative 2y is 4y. And negative 2 times 3 is negative 6. And I'm gonna write this underneath this so that they're lined up. Yeah,
I mean, it doesn't matter which, either 3 or 2, we could change the sign either way, it's still the same.
Yep. If we had done the other way, this would have been negative 6x, negative y, and negative 6. And this would have been 6x minus 4y equals positive 6. But the end result, when you, no matter which way you had gone, when you add these up, the sign here might be different, but the result is going to be y equals 0 for no matter which way you did it. Now plug into an original. Do not do one of our modified equations. Go all the way back to an original. I'll go to where 3x minus 2y. 3x minus 2 times 0 equals 3. So 3x equals 3, x equals 1. Our solution is 1, 0, but we need to verify. Let's check it. In the originals. So 2x plus 3y equals 2 becomes 2y plus 3 times 0. Does that equal 2? 2 plus 0 equals 2. That works. Now we'll check it in the other one. 3x minus 2y equals 3. 3 times 1 minus 2 times 0. Does that equal 3? 3 minus 0 does equal 3. We verified it in both, it works. 1,0 is our solution.
So on a graph, that would be the point where they intersect.
That would be the point where they intersect on the graph. Yeah,
Could we also, in this instance. Say take 2x plus 3y equals 2. And minus 3y over and then divide that side by 2.
that is called the substitution method. We'll do that in a little bit.
Oh, okay, I was gonna say. I feel like-
It does work, and oftentimes it leads to fractions, which no one wants to deal with fucking fractions. And so like the elimination method never, you might end up with a fraction because the solution has a fraction. But that you're gonna get it either way. The less you have the fraction, the better. I think. Why don't you guys try to do the same problem but eliminate y first? You already know what the solution is gonna be. It should be 1,0. So why don't you guys try doing that? And we'll go over it in, I don't know, 3 or 4 minutes.
What you say, give it y?
Yeah. We got rid of x's here, we're gonna get rid of y's now. After class or during break, you can come grab your midterm if you'd like. I remembered to bring them today. I did a good job.
Is there something similar to this with parabolas? You could kind of,
That is called a nonlinear system of equations, and we will do that later. That is 13.4. I think we had that on our syllabus.
where there would kind of be two different.
It doesn't even necessarily need to be parabola. We have parabola and cubic. Parabola and a line, parabola and absolute value.
Slapping.
As long as one of them is not a line, it's called a nonlinear system. And that's how a lot of stuff in reality tends to go. But there are scenarios. We're going to do some word problems with this a little bit. Yeah, we have 13.4 scheduled, which is that section. But not until we finish chapter 12. For some reason, Alex would not let me do the rest of chapter 12 before I covered 13.1, 13.2. He fucking said, you need to do this other shit first because they're gonna use it. I don't see where, I don't see like, they're like. I don't know why. But there's a connection between the topics, but I don't think you need to do this thing before the other.
Somehow I feel like we did part of this like earlier, like this is like a recap. But I don't know.
I don't know, we might have, it might have been in the review.
So,
We do substitution a lot.
yeah, I was gonna say, feels familiar.
Alright. So. Give you one more minute and then we'll do this together. Verdict so far, Jackie?
I got it.
That's not what I meant by verdict.
And it's awesome.
Easier than,
Circles.
is it equivalent to circles?
Yeah, it's good like circles.
Okay, good. Is that because this stuff's easier or because you're getting better at math? Maybe both?
Maybe both, maybe just addition and subtraction makes sense. If you go any further, it's a little hard.
Well, you had to do some multiplication.
Well, that's still addition.
Yeah,
Yeah.
divisions, subtraction as well. Exponents is multiplication, which is therefore addition.
Oh.
Yes, exponents are repeated multiplication and multiplication is repeated addition. So even exponents boil down to addition.
Yes.
Yeah, that's deep.
Wait, what would multiply the exponents be?
That just ends up being repeated multiplication, just repeated multiplication of repeated multiplication, which turns into addition in there somewhere. Alright, so if we do equal but opposite here, I am multiplying this top one by 2. And this bottom one by 3. And they already have opposite signs, so I don't need to change the signs. That's pretty handy. That was very nice of me to save that part for you. We have 4x plus 9y equals 4. And 9x minus. What am I doing? 4x plus 6y. There we go. Why don't we try that? 9x minus 6y equals 9. So I add vertically and I get 13x equals 13. X equals 1. I'm gonna plug that boy into this one. Two times 1 plus 3y equals 2. 2 plus 3y equals 2. Subtract 2, I get 3y equals 0. Divide by 3, I get y equals 0. And together we get the point 1 and 0.
Question,
Yeah,
would it be a -2 that we're multiplying, like the top where it says x is 2, would it be -2 because it's already?
do we need to do it? Because we already end up, without doing a negative, we end up with opposite signs.
Okay. Okay, I see.
So if they have opposite signs already, you don't need to do a negative. I personally, like in this case, if I were choosing to do eliminate x or y, I would choose to eliminate y for that very reason. Because I don't need to multiply by a negative, which means there's less chances of fucking up.
Cause I did, like, I don't know, my brain like switched it around, but I still got the same answer.
If you multiplied by a negative, this would have been negative 4x minus 6y equals negative 4.
And then I made the 3 a negative,
So you done both negative.
yeah,
Okay, so you cancel it out, yeah.
okay,
Generally, don't do the negative unless you have to. And if you have to, you should only have to do it on one of them.
okay.
Otherwise, they're already, if you have to do it on both, they are already opposite signs.
I didn't
It's good
think about
practice.
that, yeah, no, I didn't think about the opposite sign, so I was just remembering the steps from before, and that's where I got negatives, but I got the same.
So choose whichever one looks easiest for you when you're choosing a variable. Whether they're opposite signs or like one of them's got lower coefficients in front. Whatever makes it easier. Let's look at another one. This is gonna come in pretty shitty. But we're gonna work with it. Now, we want to get x's and y's on the same side. This current one doesn't have it. The one on the left doesn't have that. So let's move the y over by subtraction first. Oops. And I'm going to move the 3 to the right side by addition. And now I don't like the decimal. So I have two options. I can either pick a number to multiply by that gets rid of it, that's small, or I can shift the decimal over 1 on each of them, which is what we'll do over here. I'm gonna do that here. I can shift the decimal over 1 on every single number. Then this is the equivalent of multiplying by 10 on the whole equation. I can multiply by 10 over here, or I can do whatever, we'll get rid of the 1.5. Anytime you have a 0.5, just doubling it, we'll get rid of that. If I multiply by 2 here, I'll have 3x minus 4y equals 6. Yeah,
So they don't have to, the numbers we're multiplying by, they don't have to relate to each other. There is no relationship between 2 and 10 at all.
not yet. I'm just getting rid of the decimals and shit right now.
Right.
Then I'll check coefficients here and see like if we're doing anything.
We don't have to balance between those two things.
Right.
So we get this changed.
Let's see, I thought this was gonna do something different. I might change one of the coefficients real quick. Give me 1 second. Where did I steal this equation? I stole this from. This, I wrote it down wrong. This should be a negative 2y. Which makes that a positive 2y, which makes this a positive 4y. That's what I want.
The question, if they were exactly the same like that, would that be like parallel lines or they be on top of each other?
We're getting there.
Okay,
Hey, Trey, you immediately noticed, and now they're the same. But if you don't notice that, and you're not paying attention, you're like, I want opposite, or maybe you did something else. Where you didn't end up seeing right away that they were opposite. I'm gonna multiply this by -1 so that I end up with. An equal but opposite coefficient. And when you add up, you get 0 equals 0. So this happens when the equations are the same line. I don't have x or y in the answer anymore, which means this doesn't depend on x relation to what? Y as much. This has infinite solutions along the line. They're the same line. Now you can't just randomly pick any point. It does need to solve the line. Easy way to do it, like any point you pick, just pick a variable. Like I want where x equals 1, find the y that works. And it will work for both. If you want where y equals 10, plug in y equals 10 and you'll find the x that works for both. These are the same line. One more example. That wasn't a question. Although I approve of you nodding and saying yes.
thank you.
X minus 2y equals 5. And negative 3x plus 6y equals 4. Let's do this together. Let's pick a variable to eliminate. What variable do you guys want to eliminate?
X,
Why, Jackie?
just X by itself.
That's a good damn fucking reason. That is an excellent reason. Let's get rid of X. So if we're gonna get rid of X, I need this one to be equal and opposite of that one. This is negative 3. Since this is negative 3, I want this to be positive 3, which means I need to multiply by 3. So this ends up being 3x minus 6y equals 15. And I'll stack the other one underneath it. And when we add vertically, both the x's and y's go away. And we end up with 0 equals 19.
Solution.
That's false. Which means there's no solution. Which means these are parallel lines. Now, I'm going to use this as an example for the substitution method. Because it's set up pretty well for it. So let's take a look at the substitution. You guys are like, I like this shit. Yeah, I wonder if I can move chapter 13 up earlier in the next semester. If fucking Alex will let me. That way people are happier leading into the midterm. I'm gonna get a lot of rumbles. Method. All right, so I got x minus 2y equals 5. Negative 3x plus 6y equals. Let's change the numbers. So we got like. Let's make that, I don't know. 8y equals 4. That way we get a solution. That's an x. So I change it so that we'll get a solution. The idea with the substitution method is isolate a variable in one equation. So you can sub it into the other. You know, that it smells so much like egg and not like gas at all. It's kind of making me a little hungry. You ever had a fart that made you hungry? It's wrong, right? On so many levels. So here, this first equation set up really well for it. This one's not. If I wanted to solve for x or y, I'm gonna have to divide through y, negative 3 or 8. And I'm gonna end up with fractions, right? Not a good choice. Here, this is a really good choice because x has already got a coefficient of 1. So all I gotta do is add 2y to both sides. And to get x equals 2y plus 5. So I'm gonna go up here and in the other equation, where the x was, I'm gonna replace it with 2y plus 5. So we'll distribute. Negative 6y minus 15. Plus 8y equals 4. And if I combine the like terms, the 8y and the negative 6y, I got 2y minus 15 equals 4. I don't know about you guys, but I don't want to work with fractions right now. So I'm gonna, no, fuck it. We haven't dealt with fractions yet, so we're gonna deal with fractions. We get 2y equals 19. So y equals 19 over 2. What's wrong, Teresa? Here, plug this back into your substitution equation. So we get the solution 24, 19 over 2. And still check your work. But I'm not going to do it here in the interest of saving time. Substitution method works, but unless if you end up with fractions, and most of times you will, it's more error prone. It's a more error prone method. And I don't know about you, but I detest making errors. All right, so where does this kind of shit come up in life? I got 3 word problems. We're gonna do the word problems. We're gonna set up the equations. But then again, in the interest of saving time, this isn't too bad, is it? So like, we don't really need to solve the problems. The hardest part of a word problem is turning it into fucking math, right? Let's focus on that. So let's do some word problems here. Does anyone need this page up longer? So, at a barbecue, 250 dinners are served. They knew they were gonna make 250 dinners, they planned it ahead of time. Children plates are $1.50, which is unreasonable, but just to keep the numbers light, we're gonna go with that. Adult plates are $2.
So,
Like I said, unreasonable. But we want like nice numbers here.
I could reason with that.
It's not gonna happen in real life. That's what I mean, not reasonable. End of the barbecue. Whoever set it up, the fundraiser made $441 in sales. How many of each plate did they sell? So. I mean, give me a section to finish writing this and put a writing still. So it looks like, let's see what we got. What kind of information do we have? We have children plates and adult plates. And the price is $1.50 and $2. So let me make a little table here. Quantity sold. We don't know, that's what we're trying to solve for, right? So let's give them variables. I'm gonna, instead of using X and Y, I'm gonna use the first letter of each one. Because I think that's a good choice, then I know right away when looking at the answer, what each one is. And so like. We know the total price they made is $441, which is like sales is like this. It's the sum of like the price times the quantity, $1.50 times C is the sales for each plate type. So like we had C equals 10, we sell 10 plates, it's $15. That makes sense? And so that comes through multiplication. Here we're gonna have $2 times 8. So like this is like a total category. This doesn't like, doesn't make sense to have a total there. Did we have a total quantity? We had 250, right? So if we look at the columns, we can make equations out of this. C plus A equals 250. 1.5 C plus 2A equals 441. So this one came from ticket quantity. And this one came from sales. I shouldn't have done that right before break. Because if anyone wants to grab their test, you're gonna have to come and drew the fire. Actually, you don't have to get that close. You can stand far enough away that you're not gonna get it. Any questions about that one? We're not gonna solve it. This is like the solving is like the same as the last ones. The hard part here was the word problems. Ooh, that one has a lot of egg going on. Let's take a break. Let's help. All right, let's continue on. Let's do a couple more word problem setups. Airplane traveling with the wind.
You can see it on the map.
Flies 3,625 miles. I should say 3,000, not 2,000. In 6.25 hours. On the way to its destination. And on the way back, against the wind. Nope. This problem's not set up for on the way back. Let's get rid of it on the way. Then it travels somewhere else against the wind. For 6.25 hours. And only covers 500 miles.
The same amount of hours?
Same amount of hours.
Okay.
What is the plane speed and the wind speed?
So time is a constant.
Time here is the same.
Yeah.
So we've got distance, we've got time. An equation that has distance and time. Is rate times time equals distance. So like, let's figure out what we got going on here. I'm gonna say, let's say P is for plane speed. And W is for wind speed. And the idea is like when the plane is going with the wind is pushing it along, making it go faster than it is already on its own. Like if you got a sailboat and you're rowing. And the wind is building the sails, if the wind's pushing you along, even if you're not rowing. And if the wind's not blowing, the rowing pushes you along, and when they're both going, they both push you along. So for the on the way, like with setup. We're gonna have the plane speed plus the wind speed is like the total speed that it's going. Which is like speed is the rate. And the time is 6.25 hours. And the distance is 3,625.
So one of them is P plus W, one of them is P minus W.
Exactly. So we're gonna have the against. You gotta subtract the wind speed because it's like pushing your boat or your plane backwards. It's the same amount of time. You got less, 500, not 5,000. So if we go along the rows here. This is what we get. If I were going to solve this. I would divide by 6.25 on both first. Even if it ends up with a decimal. Because then I just got P plus W and P minus W. And that shit adds together really well and really easy, and all the coefficients are small. It's fucking beautiful. Who's there?
Luke,
What?
Luke,
Glue?
Luke,
Loot?
look out, there's a part.
You gotta be a father, that's a terrible bad joke.
I was like, bro, you have 8 kids, what?
That's a bad one. Does anyone need that longer? So one an idea from chemistry. How many grams of pure acid? Would it take? Or must be added? To make. A 20% solution. Let me say this again. How many grams of pure acid must be added? Let's just get rid of the. Do that. How many grams of pure acid must be added? To a 20% solution. To end up. With 95 grams. Of a 50% solution. You know what? They always do these fucking chemistry problems in here and they do it with fucking acid. And I get it because it's a fucking, works in chemistry and we're at school. But this problem would be so much more interesting if we were talking about alcohol content. You know, and like if I wanted to mix like Everclear and say a wine cooler.
Yeah.
To end up with something that's around 50% alcohol content, which is still fucking really high.
I'm cool with it.
Right, so like, yeah, so that would be a much more interesting process. If you never had Everclear, it's 195 proof, which is 97.5% alcohol. It'll fucking strip the fucking enamel off your fucking teeth. It'll take the paint off your fucking car.
You could put it in your car and use it as gas.
I have taken a bottle of water. Unscrewed it, take a sip out, like put like one of the Kool-Aid packets in. And put a cap full of Everclear in. And it was strong enough that one bottle fucked me up.
Well,
That's how the like, one cap full in a fucking 16.9 ounce bottle. And I was fucking trash.
and imagine taking 5 shots of it because your friends told you it was vodka.
Oh, that's not right. That's fucking.
Die, bro.
Yeah, literally.
It depends on how quickly you're doing. I've done more than 5 shots of, well, 5 shots, that's like several calories per shot.
Yeah, dude, that's.
Oh my god.
Yeah, dude.
Yeah, no shade for it.
That's an OD, bro.
No, you were a fool if you didn't realize that was vodka.
It looks like it's clear, dude.
No, but like the fucking burn,
Wow, yeah.
the burn of vodka and the burn of Everclear are
But it's
different.
already like on another level to begin with.
Yeah, we already fucked up.
Yeah, and then they like bring that out and you don't realize.
That's
what it
fucked
is.
up.
Yeah, no, they work.
Alright, so the idea here is like, we've got a 20% solution. And we've got 100% solution. And we want to end up with our final solution to be 50%. So like, how much do we got here? Amount in grams. The final solution needs 96 grams. And I don't know how much we have of each. So I'm gonna give these a variable. The 100% was the pure acid, so I'm gonna give it a P for pure. And the other one's 20% is not that strong, so I'm gonna call it a weak acid. We'll go with W. Which in hindsight isn't a good choice because we did P and W in the last problem, but they represent different things here. So this would be W and this would be P. And so like. If I multiply this, I've got like this will be the quantity that we have. I'm sorry, this is not the amount in this is the amount in grams of the whole solution. And this will be the quantity of the acidic part. In grams. Just like Everclear, you got a lot of water and you mix in the cap full, like most of the content isn't Everclear. It'll be pure acid here. So like gram wise, I don't know how many grams 60.9 ounces is, but this is gonna end up being, when we find the quantity here, we gotta multiply, but we don't do percentages as is, we turn them into a decimal. And this one would be 1.00 P. This is like my concentration column, like how strong is it? So we multiply these together to get those, I should multiply these two together. 96 times 0.5 is 48. So we'll use the columns here. Because this gives us two equations. With two variables in it. W plus P equals 96. And 0.2 W plus 1 P equals 48. If I were to do this, I would probably multiply by 5 here. Just to get rid of the decimal. Or I could multiply by 10, let's do by 10. Most people will recognize by 10. This turns it into 2W plus 10P equals 480. And now I can work with the two together. All right, you guys good with writing this down?
Yes.
Let's take a look at 13.2. Nope, some people are still writing. Just to back the fuck up. I ain't done. Still happy, Jackie?
Yeah, we're still good.
2 days in a row? What the fuck? Oh, I need to change some shit up. Next week's gonna have to have something she hates.
What the?
I can't have you happy.
All the first part of the semester.
You're not making up for it?
Yes, you're being kind now. Thank you for not giving me advice. Appreciate it.
You're welcome. I'm glad that you're happy now. All right, 13.2. Three by three and larger systems. A 3 by 3, we're gonna have something like x plus y plus z equal, I don't know, like 10. And we're gonna have 3 of these. This is a plane. Like a 2-dimensional flat surface plane. Like this table. So, and we're gonna have 3 of these. So like 3 planes, I could have them like. They don't intersect at all, they're all fucking parallel. So no intersection. I could have it, so like here, I'm gonna do the plane coming out of the board. And then doing this. So like these are the planes coming out of the board. Again, no solution. I could have. Let's see if I can do the picture. And we could have. Where they are all intersecting. Right there in a line. Kind of like you would see on like a gear or a turbine if it's kind of long. So here the intersection is a line. Or we could have it where. So it's intersecting right there. And we will have. A plane that's like this, God, this is terrible. Doing like this. Like, just like taking 3 of them, making them all like perpendicular. They only intersect at a single point. They don't all have to be perpendicular for this to happen. And when you're doing planes, you don't actually say perpendicular. We say orthogonal, but that's 3D calculus. So we could have a single point, we could have a bunch of points. So like infinite number of answers here. Infinite right here, right, that's in blue. So infinite. 0 and 1. Infinite points. Along the line. So it's the same outcomes, 3 outcomes as before. 1 outcome, 0 outcomes, or infinite outcomes. But the setup's a little bit different. They might tell you to do something in row echelon form. Row echelon form is making something look like this. I'll say 2z equals 9. Y minus 7/2 z equals negative 17/2. And z equals 3. The row here is kind of like the diagonal. Diagonal with coefficients of 1. And nothing before it. Over here is dead space.
That would, so this would be kind of like if I had 3 different kinds of concrete and I was trying to build a structure. And like Z3 would be the center pile, like a big tent.
I assume that could work.
And then like the exterior would be that top division. It's like I'm gonna need a lot more of it in 3 dimensions.
I don't know. I'd have to, I don't want to say that's a good setup or not, without looking at like, it's too big.
It's kind of,
The idea here is to back substitute. That's what they're gonna call it, back substitution. Cause normally we don't start in this form, we resolve to this form, and then we back substitute, cause we've got z equals 3 right now. We're gonna take z equals 3 and plug it in there. Y minus 7 halves times 3 equals negative 17 halves. So y is minus 21 halves equals negative 17 halves. I get y equals 4/2, which is 2. And then we back substitute both of these up into that one. I'll do this in green. X plus 2 plus 2 times 3 equals 9. X plus 8 equals 9, so x equals 1. And our solution is 1, 2, 3. And again, check your work kind of thing. This isn't any different than the other one, we just got more variables, right? This is what we did in the other one. I didn't call it row echelon form. But we got it down to where we had one equation with one variable. And we got the variable by itself. When you think about it, when we're doing x and y, we either got x by itself or y by itself. And then we took it and plugged it or back substituted it into the previous equations. Yes, Jack?
When we did back substitute it, did we not put the x on here at all, like for the first equation, we wouldn't put x plus?
Well, these don't have x, this doesn't have x, and this one doesn't have x or y. Right now, we're gonna take the z here, we're gonna plug it into this one, because we can find the y if we plug it in here. Does that make sense? And once we have this, now we have both y and z,
Okay.
and we
makes
take that and
sense.
plug that in here. So,
Is that how we notate three-dimensional points?
yes,
It's just a 3.5.
so three-dimensional point comes in the form x, y, z is usually the coordinates. And usually the way we do it, it looks a little different. This is y. This is z. And x comes out of the page and into the page. You'll see, that's a Calc 3 thing. So if you're going down the road for engineering, you'll see three-dimensional calculus. It's not too bad. It's just a way of just finding, like, if I called the corner 0, 0, 0 in here, I could have a coordinate system for how far I am this way, how far back that way, and how high up in the room I am.
This one would be x, that one would be y.
Right, so I can give a coordinate system to the clock and the projector, and they're both gonna have the same z because it's the same height. But like,
Things you value the different x and y values, or actually just.
one of them is the only one really gonna different is either the x or the y, however we define the coordinates. But let's not worry, that's some later shit, we don't need to do that, just three-dimensional, you don't need to picture it, just know how to solve it, it's doing the same solution kind of thing, same steps. So, to get to that point, we're gonna do the elementary row operations, and they're very much what we've been doing in 2D. When we did the 2 by 2. But there's some additions. Here we can swap 2 rows. If it makes it so it's like easier. Swap 2 rows, doesn't change anything. We can multiply an equation by a constant. And we don't want that to be 0, because that would zero out everything. We've done that, we did B, we've multiplied equations by numbers. And C, we can add equations to replace them. Or multiple of an equation. And replace one. Alright, so, let's just. Set up a system here. So we're gonna try to reduce this to row echelon form. So we have X, Y, Z on top. Just Y, Z in the middle. And Z on bottom. So. I wanna first off eliminate X's in these two rows. So it's A, eliminate X in first two, or last two rows. Well, no, really, that's B. A is make sure X in top row has a coefficient of 1. But that's already done. But maybe I shouldn't have, we need to have it in there. So what I'm gonna do to get my new matrix or my new like system after I've done this, I can add. Let's label these A, B, and C. If I add A plus B together, I'm gonna get rid of X, right? So let's replace that, slot that into B when I do it. So if I add X minus X, I have 0X. Y plus 3Y is 4Y. Z plus 2Z is 3Z. 2 plus 8 equals 10. So that's what I did here. I added A and B together. And I replaced B with that new equation. Does that make sense so far? Well, this is basically what we did before. I didn't show it replacing it. We just left it written somewhere else because there's only two equations. Here it's easier to keep track of it like this in this little system. So I added these two equations. If I want to get rid of the 4x here, I need to do -4 times A plus B. Or -4 times A plus C. I'm gonna write out what -4A is real quick. And we're adding that to 4x plus y equals 4. So when I add these two together, the x's go away again. And I have -3y minus 4z equals -4. I add these up, 0, -3, -4, -4. So this is the -4A, and that's the C. This is really still the same shit we did in the last one. I'm just going a little bit faster. But I actually wrote them down here, just like we did last time, when we want to get rid of variables, we have equal and opposite coefficients. Right? That's the goal. We want equal but opposite coefficients while we're eliminating. Rather than writing 0x, I think I'm gonna leave that blank. Alright, so next step. Top line looks good. We want. Well, I said A and B here, that was a terrible choice like there. Like step 1, step 2. Step 3 is gonna get coefficient of y equals 1. On middle line. So I had 4y plus 3z equals 10. I'm just gonna divide by 4. And this line becomes y plus 3/4 z equals 10/4, which is 5/2. And the bottom line is still the same. Any questions? Like I'd rather resolve these questions now before I keep going. I want to make sure everyone understands what I've been doing. If you don't understand something, say something. Okay,
I get lost a bit, I think. So we want to combine A and B. The first step here is x in the top left at the coefficient of 1. So just the x there.
yeah, and we got that already. It came that way.
We got one coefficient of 1.
Next step is we're trying to get rid of these x's right here.
And then to do that, we want to combine A and B and then combine A and C
Yeah,
in a way that eliminates x.
right. And I could have, before I got rid of B, I could have actually combined the combinations of B and C to get rid of, change C also.
Yeah, it could have been any
As long as I get rid of the x's in both of these second rows.
so that there's only one x left.
So there's only one x left is in the top row.
And then when we get to the next.
That's what we got here. Now we're gonna do we want to get this to be a coefficient of 1, just like we had a coefficient x here, 1 here. Once we get this down to a 1, now we're gonna eliminate this y. So that's step 4. Eliminate y on the bottom row. So this is like my new B. And my new C. And so if I add, I need the opposite, they're already opposite signs. So I just need the same coefficient up here. I need 3 times B plus C. And we're gonna slot that into where C was. So 3 times B is 3y plus 9/4 Z equals 15/2. That's the 3B. And C is just the same line that we had. I'm gonna write this as -16/4Z. And we'll do this as over 2. We'll do this as -8/2. So that when I add vertically, the y's go away. And I'm adding 9/4 minus 16 force Z equals 15/2 plus -8/2. So I just got the common denominator or denominator on both sides. This is -7 force Z equals 7/2. I didn't line it up. I want it to line up. It looks so much better if it's lined up. And right now we are at this. So see, we're getting a diagonal. We're trying to make that diagonal line with coefficients of 1. So what do I gotta do to finish this up? Not quite. We want to get Z to have a coefficient of 1. So let's get, where did my green pen go? So finally, well, not finally, step 5. Coefficient of 1 on Z on bottom. And that's as simple as multiplying this by -4/7 and this by -4/7, multiplied by the reciprocal. If I do that, my new system is the 7's cancel. And I've got -4/2, Z equals -2. Now that is in reduced row, or that is, yeah, reduced row echelon form.
Is there a reason we would multiply by the reciprocal and not just multiply by 4 and solve?
If you want to just multiply by 4, you're doing the same thing but over 2 steps. Because you're gonna multiply by 4, but then you gotta divide by -7. That still works. So as long as you get Z by itself, you could fucking divide by -7 force if you're a fucking psychopath. All right, now we back sub. Step 6, back sub. Y plus 3/4 times -2 equals 5/2. This is Y minus 6/4. I'll change this to have a denominator of 4 real quick. That's 10/4. So Y equals 10/4 plus 6/4, which is 16/4, which is 4. So I've got Z equals -2. I've got Y equals 4. And we're gonna take both of those and plug them in up here. And I'll do that in blue. X plus 4 plus -2 equals 2. X plus 2 equals 2, so X equals 0. And our XYZ coordinate is 0, 4, -2. There's a lot going on here. I think we'll use a little bit of next Tuesday to do a little bit more of this. And then we'll work on 12.4. And then on Thursday, we'll do like The rest, if we don't finish 12.4, the rest of 12.4 and 12.5. We might be able to start 12.6, which would be nice. I want to talk about a little bit more before we. I'm not gonna work out the examples, but we're gonna work them out on Tuesday, so if you want to give them a try. Before we get to that though, let me point out, so, infinite solutions. Has the same indicator. As 2 by 2. We had 0 equals 0. Or, 1 equals 1. You're gonna end up with a true statement and there's not gonna be any variables left. No solutions. You're gonna end up with 2 numbers that are not equal. Which is false. That was just like the 2 by 2. So let me write down some problems we will do on. For Tuesday, try to solve at home before then. Three x minus y plus 2z equals 2. 4x plus 2y minus 7z equals 0. Let me see, make sure I've got all the right values here. 4, 2, -7, 0. And then 2x, 3y minus 5z equals 7. That'll be problem 1 that we'll look at. Two x minus 2y plus 2z equals 8. 5x plus 2y minus 3z equals 2. 4x plus 3y minus 4z equals -2. Make sure I got all these values right. 4, 3, -4, -2. 5, 2, -3, 2. 2, -2, 2, and 8. We had x plus 2y plus 6z equals 5. Negative x plus y minus 2z equals 3. And x minus 4y minus 2z equals 1. Now, I took these from the odd questions in the text. And they have solutions of the following, and we're gonna see if this is true on Tuesday. But you'll know, like, if you get the same thing, you're like, okay, yeah, I did it right. This should be 1, 5, 2 when you're done. This should be infinite. And this should be none. Then if you're feeling really bold, like you get these 3 down, you're like, I want a little more practice. This is Keith. Keith does this shit. He likes lots of practice. More power. 2x minus y plus 3z plus 4w equals 9. What? 4 variables, which means we need 4 equations.
And that would be the equation of a cube.
No.
No.
This is 4 dimensions, so I can't draw it. But one of them could be time. No, it doesn't make sense to add time like this. So this isn't something I can show in like 3 dimensions. Cause it's 4 dimensions. But there are problems that have 4 different variables in reality.
Could be like velocity. That would be fine.
That's all the time. It's more of us like business related and other things like that. You got 4 different variable or things that change.
Or maybe
I don't have the solution for this one right now, and this was like an even numbered one. And then we'll actually look at some examples where like, where does this come in? So like, we have 3 points. 1, 2, 2, 1. 3, -4. Find A, B, and C such that y equals ax squared plus bx plus c. So 3 points on a parabola. So this is how it ties into like 12.1, 12.2. Or 12.2, 12.3. And we can also look at like, we'll do another 3 points. 3, -1, -2, 4, and 6, 8. Are 3 points on a circle. X squared plus y squared plus dx plus ey plus f equals 0. Find D, E, and F. And you may like, there are scenarios where you've got 3 points and how to find the problem. I know, my buddy was set up his D&D character and there was 3 points where his shit changed. He's like, I want an equation for this so I can plug it in Excel and it automatically calculates. He's like, I don't know how to do it, and I fucking went and did it, and yeah. It was D&D stuff, but like, that's not the only thing. Anytime you have 3 points and you want a parabola, this is how you find it. Peace, get the fuck out. If you want your chest, come on up and stop me and ask for it.